Good morning, all. So we'll start. See, for as far as 8051 is concerned, so all the peripherals are covered. So go through that detail interfacing diagram and code, because once you understand for 8051 microcontroller, so it is very easy to go for peak microcontroller. Only the thing is the assembly language is different, programming language is different. In 8051 microcontroller, you are using the assembly, and in peak we will be using the C language. Okay, but the logic of interfacing, the logic behind that task, everything is same. Only you have to represent that in the C language. That is the only change. But the controller concept, the controller basics related to the 8051 microcontroller and peak microcontroller are mostly the same. Only some advanced features are available with a peak microcontroller, so that you have to study. So revise the 8051 topics again in detail, then you will understand the peak microcontroller very easily. Okay, so already I told in the same subject you need to study the two microcontrollers. So by the when the first microcontroller completes, again immediately you have to start with the second microcontroller. So for that, so as to avoid the confusion, you have to thoroughly understand the 8051 microcontroller and the task completed with the 8051 microcontroller. Okay, then and then only there will be no confusion between the 8051 and peak microcontroller. Rather, you will enjoy the learning of peak microcontroller, the beauty of peak microcontroller, the advanced features of peak microcontroller. So that is important thing. So all the features we are going to study with the peak microcontroller also. But before starting that peak microcontroller, first keep in the mind is always do the comparative study. So what are the features available with the peak microcontroller and what we have studied already in 8051 microcontroller. So if you keep this type of approach, then it will be very easy to understand the peak microcontroller. So no need to go for the any confusion, all type of problems related to the understanding. Okay, so we'll start the peak microcontroller. So basically peak is again a 8-bit microcontroller. So what I told at the time of 8051 is very first and important thing is what is the size of that microcontroller. So 8-bit. So what is the significance of 8-bit? What I told, what you come to know from 8-bit? Yes, 8051 is a 8-bit microcontroller. Peak is also 8-bit microcontroller. So what do you come to know from 8-bit? Yes,
256 memory locations.
not directly the 256 memory locations. Basically, 8-bit is ALU size can handle, ALU can handle the 8-bit of data. That microcontroller can handle the 8-bit of data, can process the 8-bit of data. Okay, so that is the main important thing. So that is related to the data memory depending upon the size. But basically, when you know the size of microcontroller, that is the microcontroller is 8-bit or 16-bit, the most important thing is it can handle the 8-bit of data. It can perform the operation on 8-bit of data at a time. Okay, so that is the basic significance of the size of microcontroller. So in 8051, that comes under the CISC, and peak microcontroller comes under the RISC architecture. So the long form is complex instruction set computer and reduced instruction set computer. Okay, so the word itself gives the meaning, that is the complex instructions and reduced instruction. So already we have studied for 8051 almost 255 instructions are there. Some of the instructions are complex instruction. Okay, and in peak microcontroller the instructions are very reduced instruction, the number of instructions are less. So I think in the previous lectures also I have completed the difference between this, but some of the important points related to the CISC and RISCs are, so most important thing is the number of registers. The number of registers in RISC are more, in number of register in CISC are less. Okay, related to the number of addressing mode. So in RISC, limited addressing modes are there. In CISC, number of addressing modes are more. Though we have studied only 4 addressing mode for 8051, but basically for CISC architecture the number of addressing modes are more. Okay, so according to that, already we have discussed the number of instructions are more in complex instruction set computer. In reduced instruction set, number of instructions are less. Okay, so see, both has some disadvantage as well as some advantage. So number of instructions are less means not straightforward instructions are available for a particular task. Means user need to write the logic for the same. Whereas in 8051 microcontroller, directly the instruction is available, which comes under the complex instruction category, and we can use that instruction to perform a particular operation. Okay, so according to that, we will see the simple multiplication instruction is available in 8051, which comes under the complex instruction. But whereas in RISC, we have to write the logic for the same. Straightforward multiplication MUL instruction is not available. Okay, so in this way, the compensation we can say, if the instructions are less, obviously no need to remember all the instructions. You can go for easily writing the logic for that task or logic for that application. But if the instructions are available, but that they comes under the category, suppose the complex instruction, the number of cycles, machine cycles required to execute that instructions requires more. Okay, so that is also a disadvantage. So risk and CISC, the basic approach, the basic difference between this, whatever the peak microcontroller we are going to study, that comes under the risk architecture. So see, the basic and the most important thing related to the number of instructions and the number of cycles required to execute the instruction. The CISC approach attempts to minimize the number of instructions per program, sacrificing the number of cycles per instruction. And RISC does opposite, reducing the cycles per instruction at cost of number of instructions per program. Yes, so what is the meaning of this instruction is, CISC has number of instructions. Okay, so that's why the code size is more, a code size is less, because the standard instruction, suppose if I take again the example of multiplication, directly I can use the MUL instruction, because the standard instruction is available with CISC, but it is not available with the RISC. So I need to write some logic, so it requires 3 to 4 lines. Okay, so isn't it? So according to that, when I consider the size of the code, so size of code is increase in RISC, but the size of code is reduced in CISC, because standard instructions are available. But the number of cycles required to execute that instructions are more in CISC, whereas less in RISC. So according to that, you have to remember the basic difference between CISC and RISC. Okay. So this is already studied in the 8051 microcontroller. So here, as in 8051 microcontroller, the clock pulse is divided by the 12. So always we do the calculations, crystal frequency divided by 12. So here it is divided by 4. Okay. So peak 18F 8, this is the series of peak family. It has only 35 instructions. Okay. And most of the peaks have 40 instructions, 50, depending upon the family. Okay, and mostly all instructions execute in one cycle. One cycle is required to execute the particular instruction. So as far as this factor is concerned related to the number of cycles, so here they have taken one example, that is 8051. Suppose the 12 megahertz crystal frequency divided by 12, so 1 megahertz it comes, that is 1 million instructions per second. Whereas suppose the frequency is 12 megahertz per peak, but it is divided by 4, so it comes 3 megahertz, that is 3 million instructions per second can be executed. So that is the basic difference between 8051 and peak microcontroller. So related to the power consumption also, 8051 consumes more power than the peak, and peak consumes the least power. So that is very important advantage of the peak microcontroller family. Why to go for the peak? Why this is so is we will discuss in the peripherals also. but a number of features are added, or the additional features are added in PIC microcontroller. So that's why the power consumption is less. No need to connect the external peripherals, external devices. So that is one of the point related to that. But again, the thing is, programming point of view, when we compare 8051 and PIC microcontroller, 8051 are easy to code. Next comes the PIC. Okay, so as far as this programming point of view, 8051 is easier one, because straightforward instructions are available. User can use that directly. So again, one more difference is 8051 manufactured by number of companies, number of vendors are available. That is more than 50 companies are there who manufactures the 8051 families ICs. Okay, but whereas PEAK is manufactured only by that parent company, that is known as microchip. Yes, this is the basic difference. This is one more difference between 8051 and PEAK microcontroller. So PEAK is manufactured only by the microchip company. So in most of the cases in the oral also, they will ask the difference between the 8051 and PEAK microcontroller. So when you study the architecture and the detailed PEAK microcontroller, then you can easily tell the difference between PEAK and 8051 microcontroller. Till now, the basic difference I have just told, that is related to the architecture, CISC or RISC, then the power consumption, then the number of instructions, number of addressing mode as compared to CISC and RISC, number of registers, number of addressing modes, time required to execute one instruction, then the we can say the companies related to the manufacturing of 8051 and PEAK microcontroller, and then PIC. So what the PIC stands for? So in most of the cases, the PEAK family ICs are given by PEAK word as it is, and the family name, that is PEAK 18F, PEAK 16F, likewise. Okay, so PEAK stands for Peripheral Interface Controller, PIC. So PIC stands for Peripheral Interface Controller, so given by the microchip technology. So most important thing is, whatever the material you want, the details you want, that is available on the microchip.com. Okay, so everything is related to that everything is provided by that microchip. So only single vendor for PIC microcontroller. Again, we have studied the difference between von Neumann and hardware architecture. Already we have studied at the time of 8051 also, but this PEAK microcontroller comes under the hardware architecture. That is, the program memory and data memory is separate. So we have seen the advantages and disadvantages. Because the memories are separate, simultaneously data can be fetched, so the speed increases there. Okay, so the basic difference between von Neumann and Harvard architecture already we have studied, but this PEAK microcontroller comes under the hardware architecture. The number of families are there for PEAK microcontroller. The families comes from 12, 16, 16F, likewise. So we will be studying the 18F family. Okay. So right now I told the difference, PEAK peripheral interface controller. So PEAK 16 or PEAK 18F series popularly used nowadays in the market. Mostly the 18F and 16F mostly are the same. Some of the changes, some of the features related to the changes, but the basic architecture remains same. So these are the number of families comes under the PEAK 18F. So in that we will be concentrating on 458 or 452 or 4220. Mostly use this. I think for the practical we have used the 452. Okay. So this is the PEAK 18F families series available with the PEAK. We have studied the features of 8051 microcontroller, only 6 to 7 features, major features. Now, the 18F, the PEAK features are categorized under different category. and that category itself are only the six to seven categories are there. Okay, so see, CPU based features, peripheral based features, analog features, spatial microcontroller features, CMOS technology, power management features, and flash features. Means these are the categories. By that category, the peak microcontroller have a specific features. Okay, but in 8051 only we have studied the five main 6 to 7 features: the size, the address lines, data lines, the memory, then interrupt, then timer, UART. That's it. And the family, the IC family belongs to which particular logic family. So that are the features of 8051 we have studied. But here in a peak microcontroller, the category is given. Under that CPU based features, some of the features are available. Under the peripheral features, some of the features are available. So such 7 categories are available. Okay. So now you will get the idea of the importance of peak family and how it is important, how it is, you can say, better than 8051 microcontroller as far as application point of view. Just you can see that rather than after the features, we will again the same scenario will be followed. One by one we will take each feature and then elaborate that. So right now you just remember the features, and again in detail I will explain at that time when we are studying an individual feature. Okay, so see, the first features related to the CPU based feature. So it is a hardware architecture. As far as the peak 18F is concerned, so near about 77 instructions are there. So C language friendly architecture is there for peak microcontroller. So peak 16 source code is also compatible with this 18F. That is the beauty. If you are working with the 16, the code is compatible for the 18F also. Okay. Then program memory, data memory, the size of program memory and data memory. Then up to 10 MIPS, that is instructions are given, but for that purpose, how it is possible? Million instructions per second, how it is possible? Because here the see the clock frequency. Clock frequency is ranging from DC to 40 megahertz. So what is DC? DC is, instead of writing 0, they have written the DC. 0 to 40 megahertz clock input is available. Oscillator clock frequency is available. Okay. So according to that, you can select a particular frequency, that range is given. So by using the PLL, you can just change from 4 megahertz to 10 megahertz. Okay. So this is available with the peak microcontroller, whereas in 8051 microcontroller, only the crystal frequency we have to stuck with the 12 megahertz. Okay. 16-bit wide instructions, 8-bit wide data path. Priority levels are there for the interrupts, whereas they are available with the 8051 also. 8 by 8 single cycle hardware multiplier unit is available in peak microcontroller. So that separate multiplier unit, 8 by 8 single cycle hardware multiplier unit is available with peak microcontroller, which is not available with your 8051 microcontroller. Then current sourcing and syncing, that is the facility is available, that is 25 milliampere. Okay. Then up to 4 external interrupt pins are available, whereas in 8051, how many external interrupt pins are available? Only 2, that is INT1 and INT2, that is interrupt 1 and interrupt 2. So see, the number of features are almost 50 to 60. So wherever you should do the comparative study with the 8051, because 8051 are only hardly having 7 to 8 features, but whatever points they are same, you can just compare. Then you will understand, or you will remember the features of 8051 separately and the features of peak microcontroller separately. So that's why I am focusing about the 8051 microcontroller. So 4 external pins are available, whereas in 8051, 2 external pins are available, 2 external interrupt pins are available. Here, 3 16-bit timer and counters are available. So there we have studied 2 timers are available, 16-bit timers are available. Okay. up to 8-bit timer counters with up to two 8-bit timer counter with 8-bit period register. That is, the total 5 timers are available. 3 timers are 16-bit and 2 timers are 8-bit. But in that 2 timers, the PWM feature is available, pulse width modulation. By changing the pulse, means we are changing the pulse, means we are modulating the pulse. So we can change the speed of the motor, you can change the speed of any device, so that at that time we will be using the important feature that is called as the PWM, which is called as pulse width modulation. Okay. Apart from that, the separate model which is called as the CCP model, that is capture, compare and PWM. Here also the PWM feature is available. So separate model is available for capturing the data, for comparing the data, and for PWM for purpose. The separate module is called, and that module is called as the CCP model. So see, right now I will just explain the long form and the importance of that. In detail, we are going to study all this peripheral one by one, same as that of your 8051 microcontroller. Okay. Then here, master synchronous serial port is available, which is called as, in short, MSSP model. So some of the protocols are there where that's protocols we have to study, and by using that protocol we can interface, we can connect the number of peripherals to your microcontroller. So that module is available. Then the up to two addressable UART module is available. So we have studied UART and UART at the time of 8051. 8051 has only one UART model. Okay. So here synchronous as well as asynchronous receiver transmitter module is available. So parallel slave port is also available, which is known as PSP. So if all the connections in all the peripherals and microcontroller, in all connections, a microcontroller is considered as a master, and number of devices which we are going to connect to the microcontroller, they are called as a slave. So that parallel slave port module is also available with 80 peak microcontroller, which is not available with the 8051 microcontroller. Now see, these are only the CPU based micro, these are the peripherals, and according to this category. So most important thing is, it is a 8-bit microcontroller. It comes under the hardware architecture. It uses the RISC computer set. It is having the 77 instructions. Here the frequency can be varied from 0 to 40. Basic features I am just revising. It is having the sinking and sourcing capacity, current sinking and sourcing capacity as 25 milliampere. It is having the 4 external interrupt. It is having total 5 timers, 3 16-bit timers and 2 are 8-bit timers with the PWM facility. Then CCP models are available, MSSP models are available, two UARTs are available, and PSP module is available. Okay. Apart from that, it is having, most important thing is, it is having 10-bit ADC, 10-bit up to 8 to 16 channel means number of input we can connect to your ADC, and with the converter module with a conversion analog available during the sleep. Okay. Means what, the peak microcontroller is having a 10-bit ADC inbuilt, whereas in 8051 microcontroller we have connected the ADC chip, ADC IC externally to your microcontroller, because the inbuilt ADC is not available in 8051 microcontroller. So this is the one more important feature, that is, if you want to connect any sensors, any analog signal to your peak microcontroller, no need to connect interface the external peripheral ADC chip, because inbuilt 10-bit ADC with 8 to 16 channels are available. Okay. This is again the most important feature. Then programmable low voltage detection model. Okay. Programmable low volt detection model means what? In peak microcontroller, the feature is likewise, if your voltage goes below a certain level, that can be detected. So that facility is available. So sometimes that is also called as a brownout reset. So the brownout reset and the same, they are related to this. So this feature is available when your voltage goes below a certain level, so that can be detected. So so these are the timers available. So how that can be detected? So related timers are available. Power on reset timer is available. Power up timer is available. Oscillator startup timer is available. So these are the timers associated with that features. And most important thing is watchdog timer is available. Very very important thing. So it continuously keep watching the microcontroller operation. So when microcontroller goes in the infinite loop, the watchdog timer will just monitor the action of that microcontroller. So that is the most important timer associated with the peak microcontroller, where that is not available with the 8051 microcontroller. Now see, these all things we will again study in detail with their circuit diagram, but right now we are just studying the features, so you should know what is available with the peak microcontroller and how they works, what are their features, what are their basic diagram, what are their logics behind the peak microcontroller, that we will study in detail at the time of that particular feature. Uh, Lastly, the in-circuit programming ICSP pins are available with peak microcontroller, through which you can easily program your microcontroller. Program means you can easily dump your code through your microcontroller. Okay. So these are the most important features related to your 18F, peak 18F family. You have to just go through the features and try to remember the features of 8051 and peak separately. Okay. So number of features are available with the peak microcontroller. Then the related to the hardware and von Neumann, right now we have studied. This is just the basic diagram of peak microcontroller. The memories, IO devices. This is the basic structure of any microcontroller rather. So program memory, data memory, and the EEPROM is also available in some of the peak families. So according to the feature, according to the family of the peak, the size of the program and data memory goes on changing. And this is the advancement in the peak microcontroller family. It starts from peak 10 up to peak 32, means 8-bit microcontroller to 32-bit microcontrollers are available. So this is the advancement in the peak family. So most of the cases in the, and it is a most reliable microcontroller which can be used for most of the applications. This is the just we can say a simple diagram, block diagram of peak microcontroller. So ALU, then control unit. So all of you know the basic structure of any microcontroller: program memory, data memory, address bus, data bus, and see the significance of hardware architecture. So data address bus and data bus is different. Address bus and data bus is different for data memory. Are you realizing the difference between von Neumann and hardware architecture? Because the data bus or address bus are separate for program memory and data memory, so that directly we can fetch the data memory content and program memory content. Okay, so they have given the sizes of data memory and data memory and program memory, the address bus and data bus size. Okay, then register, as we have seen, the peak microcontroller comes under the RISC, and RISC has large number of registers set. So here the registers are also called as a file. Okay, so number of registers are there: blank select register, bank select register, file select register, program counter is also available, instruction decoder is available, status register is available, and WRREG, that is called as a working register. So working register is same as that of your accumulator register in 8051 microcontroller. Okay, so this is just you can say according to the features, some of the things available in this diagram. The most important thing is it is having the hardware architecture. So program memory and data memory is same. That's why the address bus and data bus for the both memories are different. Okay. and working register is same as that of your accumulator register, and status register is same as that of your PSW register, program status word. Here also, when peak microcontroller performs any operations, whatever is the status of that operation, that can be provided by the status register. Okay, so see, this is very very simple, but this is actually the architecture of your peak microcontroller. So you can you can see in the book also. And again, by the same way, what I have done in the 8051, making the part of that architecture, and I will try to explain the architecture in detail to you, okay, by using the parts of that architecture. In one shot it is not possible. So this is actually the architecture of peak microcontroller. As per the features, it is having the timer, it is having the ADC, it is having number of resistors, it is having some models, say specific models, SCP models, it is having the USART. So all this is available in your architecture. So we will see one by one part. So see here, total 5 ports are available. 5 input output ports are available. How many ports are available in 8051 microcontroller? Four IO ports are available. Okay, so according to that, so some of the things they have given in architecture part. So this is port A, this is port B, and C. We will see again in detail the port structure as well as the pin diagram of 805 peak microcontroller. But here port A, the name is given as port A, port B, port C, port D, and port E. Such 5 ports are available, and the name of that pin is RA0, RA1, RA2 likewise. So what is the naming convention of port in 8051 microcontroller? P0.0, P0.1, P0.2 likewise. Okay, so here according to the port name A, B, C, D, E, RA0 likewise, RB0 likewise, the naming convention is given. And the feature of that particular pin, apart from IO, all the pins are multifunction pins in peak microcontroller. Whereas in 8051, only port 3 pins can be used as a multifunction pin. Remaining port 0, port 1, port 2, they are specifically used as a input output pin. Okay. So here the data latch, data memory is available, program counter is available. So here program memory is available, and by using the number of registers, they can be accessed. Okay. So here also port C and port D is shown. So here the one of the feature of 8051 is 8 by 8 multiply unit is available. So here directly the multiplication is available and product is available in this register. Okay, so the oscillator, then the power of timer, so all these are available here. Then the ALU section, so here is the ALU. So from this the data can be from the data bus, the data can come to your ALU, the operation is performed, and again through the bus it is available on the data bus. We can take that data in the corresponding register. So we have seen port A, port B, port C, port D, and port E. But the port E is having only 3 pins. Okay, whereas port A is having 6 pins. Port B is having 8. Port C is having 8 pins, and port D is also having 8 pins. Only port A and port E are not having the 8 pins. It is having for port E 3 pins, and for port A 6 pins are available. Okay, and whatever the features we have seen, the timer, then the ADC, 10-bit ADC, then USART, MSSP model, then the comparator, then brownout reset, all these are available with the architecture. So whatever the features we have studied, and all this is related to the brownout reset, watchdog timer, all these extra features are available with your microcontroller, peak microcontroller. So see, this is actually the architecture, and this is the part of the architecture. So we will again study in detail what are the registers available, what is the organization of data memory, what is the organization of program memory, then ALU, how ALU works, the timers in detail, USARTs in detail, ADC in detail, what is the significance of CCP model. All this can be explained at the time of that particular topic. Okay. As far as this peak microcontroller is considered, arithmetic logical unit is there, instruction decoder, so as to decode the instructions, 16-bit instructions are there. Then status register stores the 5 bits. 5 bits are available, but status register is a 8-bit register. And working register, right now I told, WREG, that is called as the working register. It is same as that of your 8-bit accumulator in 8051. So you have to just correlate what is the use of accumulator. While performing the operation, one of the register should be accumulator. The data is available in accumulator. So here instead of accumulator, here it is called as a working register or W register. Okay. Then program counter. Program counter is also there. 21-bit register is there. Program counter register is available. Bank select register is also available, which is called as a BSR. Then file select register is also available, which is called as a FSR. We are going to study in data memory organization in detail what do you mean by BSR and what do you mean by FSR. Control unit is also available, that is the part. Then address bus, 21-bit address bus for program memory and 12-bit address bus for data memory. Okay. So as I told, the program memory and data memories are different. That's why the buses required for that are also different. As far as this address bus is concerned, the 21-bit address bus is available for the program memory and 12-bit address bus is there for the data memory. So according to that, the addressing capacity, memory addressing capacity is 12 megabytes and 4 kilobytes. Okay. Then the data bus, 16-bit data bus for the program memory and 8-bit data bus for the data memory. Control signals are read and write. Mostly used control signals are read and write. Okay. So these are the address bus and data bus. So in 8051, 16-bit address bus and 8-bit data bus was there because it is having the von Neumann architecture. Program memory and data memory is the same. So that's why only 2 buses are available. Here total 4 buses are available. 2 address bus for program, 2 address bus for program and data, 2 data bus for program and data memory. And the size is mentioned here. Then right now I told ki how many ports are there in peak microcontroller. Total 5 ports are available, A to E. And I have given the size of that port also. Port A and E is not having 8 pins, but port B to port D is having 8 pins. Port A is having only 6 pins, and port E is having the 3 pins. And most important thing is most of the IO pins are multiplex and they can be used as a multi-function pin. Okay, so we'll see again in detail at the time of pin diagram. So timer, serial communication, AD converter, parallel, EEPROM is available. 77 instructions are available. So according to the size of the memory, the size of the address bus, the size of the memory. So this is actually the program memory and data memory. So that's program memory and data memory organization is available. That we will study in detail in the next lecture because it is very lengthier one. So you will not understand that and the time is almost over. So we will take the attendance and then you can go for the next lecture. You can log in for the next lecture. Today is 9, na? 10, 10. Give me the attendance. Roll number 1.
Present, ma'am.
Roll number 2.
Present, ma'am.
3.
Present, ma'am.
4. 4. 5.
Present.
6.
Present, ma'am.
seven,
Present, ma'am.
8,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13,
Present, ma'am.
14,
Present, ma'am.
15, 17, 17,
Present, ma'am.
18,
Present.
Present, ma'am.
19,
Present, ma'am.
20, 20, 21,
Present, ma'am.
22,
Present, ma'am.
24,
Present, ma'am.
25, 25,
Present.
26,
26 present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Present, ma'am.
30,
Present.
31,
Present, ma'am.
32,
Ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
46, 36, 37, 38,
Present, ma'am.
39, 40,
Present, ma'am.
39 is present,
Present, ma'am.
40,
Yes, ma'am. 39%.
Present, ma'am.
41,
Present, ma'am.
42,
Present, ma'am.
43, 43, 44,
Present, ma'am.
45,
Present, ma'am.
46, 47,
Present, ma'am.
48,
Present,
49,
ma'am.
Present, ma'am. 49%.
50,
Present,
50,
ma'am.
51,
Present, ma'am.
52,
Yes, ma'am.
53,
Present, ma'am.
54, 5,
Present, ma'am.
56,
Present, ma'am.
57,
Present, ma'am.
58,
Present, ma'am.
59, 59, 60, 60,
Present, ma'am.
62,
Present, ma'am.
62, 63,
Present, ma'am.
64,
Present, ma'am.
65, 66, 66,
Present, ma'am.
67,
Present, ma'am.
68, 68, 69,
Present, ma'am. Present, ma'am.
69 present है ना,
Present, ma'am.
70,
Present, ma'am.
71, 72, 73, 74,
Present, ma'am.
75,
Present, ma'am.
76,
Present, ma'am.
77,
Present, ma'am.
78. So at
Ma'am.
least just go through the features, and if you are not getting anything, you can discuss with the in the next lecture. Features are somewhat complicated, means extra features are available, but definitely we will just elaborate at the time of that particular topic. But try to understand the basic features of peak microcontroller. Okay. In the next lecture, we will study the memory organization. Please
Ma'am,
go on.
roll number 4 is present. Her mic is not working.
Yes, you can leave. Thank you all. Join the next lecture.